picture right here.
This is lesson 413, circles in a coordinate plane,
Lines
part
J and
1.
K are tangent to circle Q. Here's line J. Here's line K. And you can tell right here the point of tangency.
The objectives in this lesson, you're going to learn to write the equation of a circle given its center and radius, and you will learn to write the equation of a circle given its center and another point on the circle.
Those are representing tangent segments. And a tangent
Let's just review circles for a second. Recall that the radius of a circle is any segment from the center of the circle to a point on the circle. And the term radius can refer to either the segment or the length of the segment.
Because their endpoints are the point.
And just a little review of the distance formula, because we're going to use it to develop an equation for a circle in a coordinate plane. You see here that D, well, this is a right triangle, and D is the hypotenuse. And that's how the distance formula is going to work, because the distance is always going to be your hypotenuse. And you see down here you have the points x1, y1 and the point x2, y2. Well, the way the distance formula works is you're going to take the x's and subtract them. That's actually giving you the length of this line down here at the bottom when you subtract the x's. And then you're going to subtract the x's right here, the y's, and that's going to give you the length of the vertical segment. Now remember the Pythagorean theorem, if you take this length right here and you square it, okay, and we're going to take the vertical leg and we're going to square its length. So remember that's like a squared plus b squared. Then it's going to equal d squared. Well, I'm going to go ahead and give you the finished formula right here. D equals x2 minus x1 squared plus the difference in y2 and y1 squared.
Have to be the point of tangency. So point C is not the point of tangency and point D is not the point of tangency, so it won't work.
Okay, now we're going to work on the equation of a circle. This is if you superimpose a circle on a coordinate plane, the center of the circle corresponds to a point, and for the equation of a circle, we're going to use the point HK as the center of the circle. So anytime you see the coordinates HK in our lessons, you're going to know we're talking about the center of a circle. And we can draw a radius from the center of the circle to any point on the circle. And in the circle equation, we always call the point on the circle is xy. So when we're studying about circles and your point is xy, you know that it's a point on the circle. Now we're going to let R represent the length of the radius, just like we had D representing the hypotenuse.
So if you look here, CD, and I've already explained that to you.
The distance formula. We're going to let R equal the length of the radius. We're going to substitute the endpoints HK for the x1, y1 in the distance formula.
So that's why it won't work.
Now what we're going to do is we're going to simplify the equation. What we're going to do is we're going to do the square of each side. So we're going to square R and we're going to square this part of the expression right over here. Okay, so what's going to happen now, after we get finished squaring it, we're going to end up with R squared equals x minus h squared plus y minus k squared.
This says segment AP and BP are tangent segments of circle Q. If AP, that means AP equals.
So the equation of the circle is going to be the difference of x and h squared plus the difference of y and k squared, which equals r squared.
If segment AP equals 3x plus 6 centimeters,
and that, the equation of the circle,
and a lot of times
right here, this is what you're going to need to remember and make note of for when you're taking a test.
It's probably not completely necessary.
All this other over here is just showing you how we developed the formula.
Here's 3x plus 6, and this one right here is 5x.
So let's go ahead and do some examples. We're going to write the equation of a circle whose center is the point 4, 1, and the radius is going to be 3.
So they're tangent segments, so they're congruent, and I already had marks there I forgot about. AP
Oops,
is
I
going to
went
equal
really fast.
BP.
No, I didn't.
So
Okay, so what I'm going to do is I've got the equation of the circle, and I'm going to replace the values that I know. And remember I told you earlier that your center
subtract 3x from both sides.
is always going to be, helps if I turn my pen on.
Subtracting 3x. That's going to leave me with 6 equals 2x minus 12.
Your center is always going to be h and k, just like on the previous slide. So what was done right here is 4 was placed, so we substituted h with 4, we substituted k with 1. And now the reason we go ahead and we put these parentheses around h and k is just in case they're negative, and we're going to see an example when they are negative. And the radius is 3, and it's going to be squared. And so we've got the difference of x and 4 squared plus the difference of y and 1 squared is going to equal 9, because 3 squared is 9. And whenever you're writing an equation of a circle, that's all you have to do. You don't have to do any solutions or anything. You're done. So you can put an X around that and call it good. Okay, now look in this one. We're going to write the equation of a circle whose center is 5 and negative 2. And remember that 5 and negative 2 represent h and k, and the radius is going to be 4. So there's our standard equation of a circle, and we're going to replace the h and k with the coordinates of 5 and negative 2. Notice how,
right here it is, 3.99.
well, maybe not.
They tell me that ED is 2.49.
Oh, I got some pen action going. I guess it only works when the arrow's on. Okay, well right here, notice how I put that negative 2 in parentheses. Now it says y minus a negative 2. You have to remember what happens whenever you have two negatives. It's always going to make it a positive. So we're going to have to go ahead and simplify this. We're not going to do anything with this equation right here. It's going to stay x minus 5. And then the y minus a negative 2 is going to end up being y plus 2. And then we're going to square the 4, which is going to make it 16. So we're going to end up with x minus 5 squared plus y plus 2 squared, because remember, two negatives make it a plus sign, and that's going to equal 16. And then that's going to be the end of the problem. You just put a square around it, say, hey, this is my final answer.
So when you work those out, and I'm just going to round to the nearest 10.
Now we can identify the center and the radius given an equation. Okay, so if we're given the equation of a specific circle, we can easily identify the circle's center and its radius. So here's the equation. The sum of x and 2 squared plus the difference of y and 7 squared equals 64. So we're going to rewrite that given equation in standard form. So here I just wrote the equation down again. Now look what I'm doing in
tell me AE is 10, so I'm going to put 10 here. EB is 6.
I've written it in standard form. So remember, whenever I have this as a positive, that means that I was actually dealing with a negative 2. So I'm going to have x minus a negative 2, and then y minus 7 squared. And remember, your radius is squared, so that means I'm going to have to figure out what is the square root of 64.
That is what's going to happen here.
So
okay, there's the formula that we're going to
I'm going to compare the above equation with the general rule for an equation. So here's the general rule right here. Well, let me put an x over here. Let me go ahead and write this out again. I thought I had and must have overlooked it.
I'm going to divide both sides by 5.
Okay, now I'm not making any changes right here. I'm just rewriting.
So CE equals 12.
So when we say that we're going to rewrite the equation in the standard form, that means I'm putting these numbers in parentheses. And then of course if that's a plus sign, you're going to have to make your number negative. oops, let me put that squared. And then the square root of 64 is going to be 8.
If AE is 5x plus 6, 5x plus 6.
So, based on comparing the equation, all right, h is going to be a negative 2, the k is going to be a 7, and the radius is going to be 8.
First, we have to solve for x. So
therefore, the center of the circle is the coordinate negative 2 and 7, and the radius is going to be 8 units long.
If you have different point names. If these were
one more concept that we're going to go over here, equations of circles centered at the origin. If it's centered at the origin of a coordinate plane, it's going to be a special case because h and k are both 0. So the equation of the circle simplifies to be an x squared plus y squared equals r squared. And I'm going to show you how that happens. Here we go. There's our standard form of the equation. And if you look down here, the center is the origin. So I'm going to replace the h with a 0 and the k with the 0. Let's see how that looks. Well, and the radius with the 5. There you go. Well, what is x minus 0? It's going to be x. Y minus 0 is y. So when I simplify that, and I go ahead and square my 5, I'm going to have x squared plus y squared equals 25. And that's going to be your answer. So what you need to remember is whenever you have a circle that's centered at the origin, your equation will look like this, always. If it's centered at the origin, that's what your equation is going to look like. Okay. Summarize the lesson. If you've got the standard form of equation of circle is given by this formula, where you got the difference of x and h squared plus the difference of y and k squared is going to equal your radius squared. HK is always going to represent your center. Your XY is going to represent a point on the circle, and your R is the length of the radius. And when the radius of a circle is not known, we're going to use the coordinates of the center of the circle and a point on the circle to determine the value of R squared, and then write the equation of the circle. And then the equation of a circle centered at the origin is x squared plus y squared equals R squared.
AE plus EB equals AB.
After you watch the video, of course, you should go to the LMS and go through the lesson 413, Circles in a Coordinate Plane Part 1, and complete the student guide. Read the lesson in the reference guide and add more notes if needed, so that way you'll have them when you get ready to take the test. And then complete the following problems in the problem set, which is 2A, 2B, number 3, and then 3 through 17 odd. And then contact me or attend TOGA if you have any questions before you complete the quiz 413. And as always, make note of any general questions you may have when you attend CC. And please add your course and section number with all communication to me, so that'll help me help you faster. That's the end of lesson 413. Thanks for listening.
After you get finished watching